Yes, good morning, everyone. Good morning, everyone. I hope you can hear me. Welcome for today's class. This is a video for recording for system analysis and design. Now, we're going to start, though we had covered this, but in case you get into the portal, you'll find these notes for your own review. I believe I've shared these notes with every one of you. Make sure you do the assignments, you do the quizzes, and you do the cards. I'll start. System analysis and design. Now, what is system analysis and design? System analysis and design is a process of designing, building, and maintaining an information system. You design, you build, you maintain an information system. Now, and the individual who performs this task is called a system analyst or a software engineer. We have said system analysis is a process of designing, building, and maintaining an information system. And an individual who performs this work is called a system analyst or a software engineer. We are going to define some terms. What is a system? What is a system? A system is a set of components that work together to achieve a common goal or objective. A system is a set of components that work together to achieve a common goal or objective. System, for example, we can have a car is a system. You find it has an engine, it has brakes, it has wheels. All this makes it a complete system. Now, what do you find? If one of the components of a system is not working, yes, what will happen? Your system will not function, but will miss a component. So all these components, when they are combined together, they work to achieve a goal or an objective. An information system. Now, an information system is a set of interrelated components. It is a set of interrelated components or technologies that collect or retrieve, process, store, and distribute information to support decision making and control in an organization. What am I saying? I'm saying an information system. An information system is a set of integrated components or technologies that collect or retrieve, process, store, and distribute information to support decision making and control in an organization. You need to know what is data. What is data? What is data? You need to know what is data. Data is a collection of raw facts, figures, and symbols which must be arranged or processed in order to be meaningful. Data is a collection of raw facts, figures, and symbols which must be arranged in order, which must be arranged or processed in order to be meaningful. Examples of data, we can have name of students and their marks in different subjects listed in a random order, or name of employees. Then we have information. What is information? Information is data which has been processed. Information is data which has been processed to a point where it conveys knowledge and represents a usable statement. It is data which has been processed to a point where it conveys knowledge and represents a usable statement. Examples: when the names of students are arranged in alphabetical order, total and average marks are calculated and represented in a tabular form. When the name of the student are arranged in alphabetical order, total and average marks are calculated and represented in a tabular form. Then we have IT. What is IT? Information technology. IT, it is a design, development, and it is the study, design, development, implementation, and management. Just a minute. Implementation and management of computer-based systems, particularly software application and computer hardware. Chapter 2, System Theory. We start by defining what is a system. Again, it is a collection of objects or components that work together to realize some objectives. Collection of objects or components that work together to realize some objectives. Now, one thing you need to know, a system consists of a subsystem. And what is a subsystem? It is a system within a system. This means that the system exists on more than one level and can be composed of subsystems. Subsystem is a system within a system, and this means that the system exists on more than one level and can be composed of subsystems. We have examples consist of software module. Software module is an example of a subsystem. Below there, we have a diagram that's showing a complete system that is made up of several subsystems, subsystem A, subsystem B, subsystem C, and you find subsystem A has system A1 and A2. All these, when they work together, they make one complete system. Components or elements of a system. Number one, a system has the following element. We have resources, we have procedures, we have data stroke information, and we have processes. Now, what are resources? Resources, they can be hardware, they can be software, or they can be liveware. I'm saying resources can be hardware, they can be software, or liveware. Now, hardware resources may include the computer, its peripherals, and stationery. Hardware may include computers, its peripherals, and stationery. Now, software resources include programs running on the computer. Remember, if you remember what we said, hardware, they are the physical, tangible components of a computer, and software, they are programs that run in a computer. Then we have liveware. Liveware resources, they include people required to operate the system and make it functional. Liveware, they include people required to operate the system and make it functional. We have procedures. Now, every system functions under a set of rules. Every system functions under a set of rules that govern the system to accomplish the defined goal of the system. Every system functions under a set of rules that govern the system to accomplish the defined goal of the system. The set rules define the procedures of the system. Now, example, a banking system have their predefined rules for providing interest at different rates for different types of accounts. Then we have data stroke information. To achieve a goal or an objective, the system requires certain input, which is converted to the required output. I'm saying to achieve goal or objective, the system requires certain input, which is converted to the required output. Processes. Now, systems have processes that make use of resources to achieve the set goals under the defined procedure. Systems have processes that make use of resources to achieve the set goals under the defined procedures. These processes are the operational elements of the system. And we have characteristics of a system, and a system has 8 characteristics. It has 8 characteristics. If I correct here, there should be 8 characteristics. Characteristic number one of a system is components. Components. A system is made up of components. And what is a component? A component is an irreducible part or aggregation that makes up a system, also called a subsystem. Remember what we said, a system is made of several components, and these components are called subsystems. We can repair or upgrade the system by changing individual components. I'm saying we can repair or upgrade the system by changing individual components without having to make changes throughout the entire system. We can repair or upgrade the system by changing individual components without having to make changes throughout the entire system. Now, the components are interrelated. The components are interrelated. This means the dependence of one system on one or more subsystems. The components are interrelated. This means the dependence of one subsystem on one or more subsystems. The function of one subsystem is tied to the functions of others. The function of one subsystem is tied to the function of others. Then we have boundary. Boundary. Now, a system has a boundary within which all of its components are contained and which establishes the limit of a system. Saying a system has boundary within which all of its components are contained and which establishes the limit of a system, separating the system from other system, separating the system from other system. Now, the boundary is the line that makes the inside and outside of a system and that sense of the system from its environment. And that sense of the system from its environment. Purpose. System has a purpose. This is the overall goal or function of a system. This is the overall goal or function of a system. A system must give priority to the objectives of the organization as a whole as compared to the objectives of a subsystem. The overall goal or function of a system must give priority to the objectives of the organization as a whole as compared to the objectives of a subsystem. Now, environment. This is everything external to a system that interacts with the system. Environment, this is everything external to a system that interacts with the system. That is, everything outside the system's boundary. Usually the system interacts with its environment, exchanging in the case of an information system, data and information. That's an environment. Now, interface. An interface is a point of contact. It is a point of contact where the system meets its environment or where subsystems meet each other. Point of contact. The interface between an automated system and its users, that's manual system, and interfaces between different information systems. It is the design of a good interface that permits different systems to work together without being too dependent on each other, Because an interface exists at the point where a system meets its environment, the interface has special or important functions outlined below. An interface should have security, buffering, and summarizing raw data and transforming them into the relevant details and format needed throughout the system. Now, still we are looking at components. We have constraints or controls. These are limits to what a system can accomplish. A system must face constraints in its functioning because they are limits. A system must face constraints in its functioning because they are limits. In terms of capacity, speed, or capabilities to what it can do and how it can achieve its purpose within its environment. Then we have input. This is whatever the system gets from its environment. This is whatever the system gets from its environment. Zero data. Then we have output. This is whatever the system returns to its environment in order to fulfill its purpose. This is whatever a system gets from environment in order to fulfill its purpose. Now, we have different types of system, and that is why we are saying classifications of system. Classifications of system. Now, systems can be classified as open, closed, abstract, deterministic, probabilistic, open group system, closed-loop system, and artificial systems. Now, we shall continue just a minute. We're going to look at different types of system from the open system, different types of systems. Continue looking at different types of system. Now, an open system. What is an open system? These are systems which are connected to and interact with the environment. Examples are the biological or social system. Now, you're being told all businesses, organizations are also open systems since they must have capacity to adopt in the future of changing competition and changing markets. Then we have closed system. A closed system is that which does not interact with its environment. The one which does not interact with its environment. Now, the system is neither influenced by nor influences its environment. It does not take in from or give to it. The system behavior occurs because of internal interactions and is more relevant to scientific and social systems. So open system is open, closed system is closed. Now we look at the differences between open and closed system. Now, an open system interacts with the environment constantly, and a closed system does not interact with the environment. An open system has an infinite scope, and a closed system has a limited scope. In an open system, relevant variables keep on interacting, and in a closed system, it is self-contained. An open system is flexible and abstract, and a closed system is rigid and mathematical. Now, abstract systems, they are conceptual. They are not physical entity. They may be formulas, representation, or model of a real system. They are not physical entity. They may be formulas, representation, or model of a real system. Now, deterministic system. These are systems that function according to some predetermined procedures and must have results and future behaviors predicted with certainty, provided they are working correctly under control. Now, probabilistic system. These are those systems which operate on probability. They are those systems which operate on probability. State and behavior can be predicted only within certain limits, even when they are under control. Then we have cybernetic system. They are the probabilistic system. Then we have open loop. This is a system which does not act in a controlled manner. That is no feedback, and so no measure of performance against standards. Then we have closed loop system. A system that functions in a controlled manner, e.g. a system accepts input, work upon them according to some predefined processing rules, and produces output so that it can function in a controlled manner. Must give feedback. Then we have artificial system. These systems are created rather than occur by nature. E.g. computer programs, organization, etc. They are usually made to support the objective of the designer and user. They're usually made to support the objective of the designer and user. Now, system properties. We have hard properties. These are attributes that enable data to be measured, e.g. cost of an item, number of employees in an organization. Now, often engineering science data has hard property that can be measured. Now, soft properties. There are attributes that are not capable of precise measurement, e.g., there is nothing an individual can use to say a material is attractive. Often, they are social and political, have soft properties. Now, we have hard systems. Hard systems. Now, problems has a definite solution, or a specific solution. Then we have soft system, whereby there are infinitely many ways to solve the problem. Problem can be specified precisely. Information system. What is an information system? It is a set of integrated components or elements that collect, process, store, and distribute information to support decision making and control in an organization. It is a set of integrated components or elements that collect, process, store, and distribute information to support decision making and control in an organization. Now, a computer-based information system is an information system that uses computer technology to perform some or all of its intended tasks. Activities of an information system: entering data into the information system, that is the input; changing and manipulating the data in an information system, that data processing; getting information output of the information system; and storing data. We have the input, it processes, it outputs, and stores. And in between, it gives you the feedback. In between, it gives you the feedback. Now, components of an information system or information system resources. An information system consists of five major resources. We have people resources, we have hardware resources, we have software resources, we have data resources, we have procedures, and we have network resources. Let us look at people resources. Now, people resources, they include end users and information system specialists. They include end users and information system specialists. End users are people who use an information system or the information it provides. There are people who use an information system or the information it provides. They can be customers, salespersons, clerks, or accountants. Now, information system specialists are people who develop and operate information system. Information system specialists, they are people who develop and operate information system. They include system analysts, they include software developers, database designers, and system operators. Those are all the people. We have started with the end users, information system specialists. We had looked at system analysts. They design information system based on information required of the end users. Then we have software developers or programmers. Now, these ones, they create computer program based on the specifications of the system analyst, and system operator helps to monitor and operate large computer system and network. Hardware properties, they include all devices and materials used in information system processing. They include all devices and materials used in information system processing. Hardware includes computers, printers, data media on which data is stored, etc. We have software resources. Software includes system software such as operating system, and application software includes system software such as operating system and application software. Then we have data and information. Data can take many forms, including alphanumeric data, new numbers, letters, images, pictures, and other characters that describe a business transaction. Then we have procedures. Every system functions under a set of rules that govern the system to accomplish the defined goal of the system. Every system functions under a set of rules that govern the system to accomplish the defined goal of the system. Then we have network resources. Telecommunication network consists of computers, communication media, and network infrastructure. Below there, We have some disadvantages of expert system. Then we have system owners. He is the owner of an information system. He is a key contributor in developing the system design specification to ensure the security and user operational needs are documented, tested, and implemented. Now, a system analyst is an IT professional who specializes in analyzing, designing, and implementing information systems. Specializes in analyzing, designing, and implementing information system. Now, types of systems. We have different types of system. We have transaction system. Now, every organization has a transactions that happen on a daily basis, and now you need a transaction system to record every transaction that happens. Now, number one, we have TPS, transaction processing system. Now, it is a computerized system that performs and records daily routine transaction. It is a computerized system that performs and records the daily routine transaction necessary to conduct the business. The system serves the operation level of an organization. It serves the operation level of an organization. A business can have several transaction processing systems. A business can have several transaction processing systems. Examples are we can have stock control system. And now they are used by operation level employees to help make structured decision. Then we have knowledge management system. Now, these are designed systems to help business create and share information. They are designed to help businesses create and share information. They are used in business where employees can create new knowledge which can be shared with other people in an organization to create further commercial opportunity. E.g., we have AutoCAD, Archicad, etc. Then we have MIS, Management Information System. Now, it is an information system. It is an information system that the management level of an organization, that serves the function of planning, controlling, and decision making by providing routine summary reports. They take data from TPS and summarize them into series of management reports. They take data from TPS and summarize them into a series of management reports. They make structured and semi-structured decision. Then we have decision support system. Now, it is an information system at management level of an organization that combines data and sophisticated analytical models to do data analysis to support semi-structured and unstructured decision making. A decision is considered unstructured if there are no clear information or procedures for making decisions. Now, components of a DSS, decision support system. Now, data management component performs the function of storing and maintaining information the DSS uses. User interface management component, it allows the user to communicate with DSS. And knowledge management component provides information about relationship, about data that is too complex for a database to represent. Characteristics of a DSS. It offers users flexibility, adaptability, and quick response. Operate with little or no assistance from professional programmers. Provide support for decision and problems whose solution can be specified in advance, and DSS use sophisticated data analysis and modeling tools. We have group decision support system. It is a type of DSS that helps a team of decision makers to solve. It is a type of DSS that help a team of decision makers to solve problems. Executive support system or executive information system. An information system is designed to help senior management to make strategic decisions. It is used at the strategic level of an organization to assist in making and structured decisions. They gather, summarize, and analyze the key internal and external information used by the business. Then we have expert system. These are professional systems that mimic or act as experts can do. Maybe you can have system that does some engineering function. And when we talk about expert system, it is a computer-based system that emulates the decision-making ability of a human expert. It is a computer-based system that emulates the decision-making ability of a human expert. They are designed to solve complex problems by reasoning about knowledge like an expert and do not knowledge like an expert and not by following the procedure of a developer as in case of conventional programming. Now, benefits of an expert system: preservation of knowledge. Expert system preserve knowledge that might be lost through retirement, resignation, or death of an expert or acknowledged person in a company. It is not to human feeling such as fatigue, being too busy, or emotional. An expert system can effectively be used as a strategic tool in the areas of marketing of products, cutting costs and improving product disadvantages. You can go through them there. Then we have geographic information system. And yeah, we are going to look at next lesson, maybe information system stakeholders. Information system stakeholders. Now, let's look at stakeholders. Information system roles of information system stakeholder. We have their owners. These are people who own a part of or who are part of development of an information system. We have number one, system owners or sponsors. System owners or sponsors. Now, providing the work of owners or sponsors, they provide clear requirements and expected project outcomes to the development team. They provide clear requirement and expected project outcomes to the development team, reviewing and approving project tasks, plans, budgets, and schedules. They review and approving project tasks, plan, budget, and schedules. Again, they review and approve scope of work, authorizes the system to be used. System users or end users, they provide source information to the development team. They provide source information to the development team. Again, provide expert business understanding of the organization. They provide expert business understanding of the organization. Again, they review and confirm. They review and confirm major software development life cycle products for the project. And this is software development life cycle. Again, they participate as required in user acceptance testing activities, as required in user acceptance testing activity. Oh yeah. Oh yes, we can continue with the information system. We can continue. Now, we have system owners. We have system owners. They provide clear requirements and expected project outcome to the development team, reviewing and approving project tasks, plans, budget, and schedules. They also review and approve scope of work and authorize the system to be used. They authorize the system to be used. Then we have system users or end users. Provide source information to the development team. Provide expert business understanding of the organization. Review and confirm major SDLC work products for the project. These are the system development life cycle. Participate as required in user acceptance testing. Now, benefits of user involvement. Why should you involve users when developing a system? Number one, there is improved quality of the system arising from more accurate user requirement, acceptance of the system. Now, when users are involved in system development, they are more likely to accept than reject it. They are more likely to accept than reject it. Now, again, they're more likely to accept than reject it. Again, when users are involved in the system, there takes short period time of training because they already understand what the system does. Then we have the system analyst. These are the duties of a system analyst. We said he collects information to analyze and evaluate existing procedures or proposed system, prepares detailed flowcharts and diagrams outlining system capabilities and processes. Again, prepares and maintains system documentation. Again, conducting technical research on system upgrade, define feasibility cost, time required, and compatibility with the current system. And again, documenting system procedures for future reference. Skills of a system analyst. Number one, he has problem-solving skills, leadership skills, and good communication skill. Now, system developers or programmers, what do? They convert software specification requirement into appropriate programming languages. They write and test the source code. They write and test the source code. Again, observing, testing, diagnosing, and fixing faults in the software. Observing, testing, diagnosing, and fixing faults in the software. Again, training system users on how to use the system. They train the system users on how to use the system, modifying and updating the system. Modifying and updating the system. We have the software project manager. Software project manager, creating clear and attainable project outcome, and again, management of the team. The software project manager coordinates software development activities, controlling budgets, confirms resources within the budget, performance monitoring. This monitors the performance against the plan and approves project deliverables. Now, in our next lesson, we shall look at software development life cycle. This video is available for you to view because you didn't attend the lesson. So you can go through the video and you will learn something. In case of any question, you are always welcome to contribute. Thank you so much for attending the class. Thank you so much for this time. I wish you well and keep safe.